Okay, the assignment for this problem is to find the voltage V1 as shown on the diagram. This is a single loop circuit containing a dependent voltage source, so we're going to utilize the problem solving strategies entitled single loop circuits and circuits with dependent sources. Okay, our first step in solving a problem like this is to assign a current, and I'm going to assign a current I1. I'm going to assign it in that direction. Okay. Then the next step of our problem solving strategy for single loop circuit says now define a voltage across all these resistors in terms of the assigned current. So the voltage across that 8K resistor would be 8K I1 with that polarity, again using Ohm's law. This voltage would be 4K I1 with this polarity, and the voltage across this resistor would be 8K I1 with that polarity. Now, in the strategy for circuits with dependent sources, we're going to treat this dependent source as an independent source when we're writing the KVL equation. Since it's a single loop circuit, we have one KVL equation. So let's start in that upper right corner and let's go around counterclockwise. So our first term here will be 8K I1. Drop there. Coming along here, we hit the minus sign. That's a voltage rise, so we write it as minus 18 plus 4K I1 plus 0.5 Vx. Come back around to here. We have 8K I1. And as we come all the way back around here, we hit the plus sign. Again, a voltage drop, so we're going to write that as plus 50 equal to 0. And now if we collect terms, we'll have 20K I1 plus 0.5 Vx is equal to minus 32. Now we need to express Vx in terms of our assigned current. So if we look at our resistor here in the circuit, we look at the voltage Vx and then look at this voltage in terms of the current, we can see that Vx is 8K I1. So now if we make that substitution, we'll have 24K I1 equal to minus 32. And then solving for I1 gives us minus 4/3 of a milliamp. So there's the current I1. We assumed it counterclockwise. The negative sign tells us the current's actually flowing in the opposite direction. Now we need to find the voltage V1. So what we'll do now is we'll use KVL and go around this part of the circuit. So we're going to go around in this direction. And when we do that, the equation that we get for V1 is 4K I1 plus 0.5 Vx. And that's 4K I1 plus 0.5 times 8K I1, which says that V1 is 8K times I1. That's 8K times minus 4/3 of a milliamp, which says that V1 is minus 32/3 volts.